Before we start, let me maybe give an opportunity to Memo to welcome us to this memorandum discussion. Memo.
Thank you, TV. Good morning, colleagues. I hope you're still doing well. Welcome to our memo discussion for grade 12 physical sciences. Colleagues, please feel free to ask any questions that you feel you need clarity on. Just ensure that you raise your hand, or if nobody sees you, we will Mr. Mhapi will ask whether there's any question as he continues. Ensure that you, by the time you leave this memo discussion, you know exactly how to mark each question. And don't say, for example, your question might sound stupid or whatever, because there are a lot of things, things that might be misinterpreted. So we need to ensure that everything is interpreted exactly as it's supposed to, and it is marked exactly as it's supposed to. And we need to ensure that when we mark now in March, we mark exactly the way we are going to mark at the end of the year. So please feel free and ask questions. As soon as a question is discussed and is done, then you will be able to ask questions. And there will be registers that you are required to fill in. Thank you. I didn't say I want to say something that I'm not.
No, I don't want to say anything. Is that colleagues also please take note of that the registers, the link for the registers is already in circulation, so please fill the registers as it is needed also. Thank you, Dr. Mahapi. We may continue.
Thank you very much, colleagues. I think we have been given a direction by our leader, then we must start with our discussion now. So before we start, colleagues, just to remind ourselves of the acceptable standard of marking, and then for the benefit of colleagues who will be marking for the first time, this is how, colleagues, we are expected to mark. When we mark question 1, you will mark a correct answer, giving it 2 ticks. If 1.1, it is option B, then you'll give 2 ticks on option B. If then 1.2 is wrong, you'll just give 1 cross there to show that it is wrong. You do not, for multiple choice questions, colleagues, you do not have to transfer the marks to the margins here for each and every sub-question. You will only close the question at the end of that multiple choice and then transfer the total of the multiple choice next to the question number, like I've done here, colleagues. And if the answer sheet does not contain the questions like here, then please write question 1, question 2. This is where you are going to write the totals for each question. So you will mark, and the total of each question will then be transferred next to the question number, like I've done here. That is how we mark question number 1, colleagues. I hope it is clear. And then when you come to structured questions, such as your question number 2, when you mark, colleagues, each sub-question will be marked, and the marks for each sub-question will then be transferred to the margins. Let's take 2.1 as an example. It will be 2.1. If a learner gets 2 marks, you'll then give 2 ticks for 2.1 and then write 2 marks to the margin or next to the margins of your answer of that sub-question, which is 2.1, like I've done here. Then you move on to 2.2. You will mark, and the total for 2.2 will then be transferred to the margin corresponding to going along with the 2.2 sub-question there. If the question then overlaps to the next page, colleagues, please indicate with an arrow that the question continues in the next page, like I have done here. So you have 2.2 and then 2.3, it is on the next page. Then just indicate with an arrow that the question continues, and then go on and mark 2.3. 2.3, if a learner gets 5 like in an example here, then that 5 will then be transferred to the margin of the corresponding to the sub-question 2.3 there. And then you add the totals of the sub-questions. Then they will give you the total of the question, which will then be written next to the question number, like it is the case here. The learner, when you add 2 plus 1 plus 5, then the total for question 2, it is 8, and then will be written next to the question number like it has been written there. And this total of 8 will then be transferred to the front page. The question 2 will then be equal to 8 marks. That is what we will do for the rest of the script for each and every question in our question paper, colleagues. I hope this is clear, and this is what we expect that you apply when you do your marking, colleagues. I believe this is clear. We'll now move on to our memo discussion. Looking at the memo discussion, colleagues. Oh, I see a hand there. I do not know who sent. I can't see the hand. If you can just unmute and then ask your question, please, Mina.
Mr. Mohapi,
Oh,
it's about, can you go down to question 2 at the bottom there in your script?
okay.
For example, if question 2.3 is like that, just colleagues need to ensure that they combine the marks and make it 5. Because sometimes colleagues would make the first calculation 3 and then the second calculation 2. We only give 1 total mark for a sub-questions. So there shouldn't be 2 marks, so that when you do your error analysis, then it becomes 1 mark, not 2 marks for the same sub-question. Thank you.
Okay.
May Emma please mute? May Emma Malashela please mute?
Okay. Now, thank you very much, Ma'am Mancho. Colleagues, let us then go back to our discussion. When it comes to the multiple choice question, we received a concern with question 1.1. There are colleagues who feel that the correct option there should be D. We just then prepared short notes for 1.1 just to try and explain why the correct answer is B. As colleagues will see from the question paper, 1.1, the diagram below shows the box being pushed along a rough horizontal surface by force F, which makes an angle theta with the vertical. It is clearly indicated in the question that the angle is made with the vertical. That is very, very important, colleagues, to note. And then the correct expression for calculating the weight of the box will then be what, colleagues? Weight. Here we are looking for an expression to calculate weight, not the normal force. Weight, colleagues. So the correct option is option B. Why is that, colleagues? If we were to draw a free body diagram showing forces that are acting on the box there, you'll have concentrating on the forces that are acting vertically, because we are looking for Fg, which is the weight. You'll have your normal force, Fg, and then you have the applied force there acting at an angle. But remember, the angle is made with the what, colleagues? With the vertical, not the what? Not the horizontal. So from here, if you resolve this force into its components, you'll then have the X components of the force and the Y components of the force. And from here, it is clearly indicated that this Fy of ours will be adjacent to the angle. And this Fsx will then be opposite to our angle, because of the position of the angle, which is made with what? With the vertical, not the horizontal. So please let us be careful of that. So if we take our net force in the vertical along the Y, we'll then have this expression here. Because the object is not moving vertically, then our acceleration will be equal to 0. And then if you make your gravitational force subject of the formula from here, it can be clearly seen, Hore, your gravitational force will be equals to normal force minus F cos. Why cos? It is cos because our vertical component of the force, it is adjacent to the angle. It is not opposite to the angle. I hope this then clarifies the concern that colleagues had on 1.1. So option number B, colleagues, it is the correct option. If there are still questions, I can see Memahola has a question. I believe it is on 1.1. Memahola?
Oh, yes. Good morning, Tate.
Yes.
I don't know if it will be correct for me to say that according to what we did in grade 11,
Mhm.
will it be right if I say that for learners, in order for them to be able to check where is the direction of FY, they
Mhm.
need to construct the triangle using the head to tail method? Because I
Mhm.
could see that F, it's going downward. It means
Mm.
that from the tail of F, then I'm going to draw or is it head to tail? Is that how it's not supposed to be like that? No, yes, I get it now. I get it.
Oh, you get it, me. Okay, thank you.
Yes. Okay.
Yes. Yeah, you can, vectors can be moved around space as long as you maintain their magnitude and direction. So if you want to close the triangle from this side, colleagues, then your fx will then move here, and then your fy will move here. Fy will move here, and then fx will move here, and then you'll see your fx will then be opposite your angle, and fx will be fy will be adjacent to your angle, and fx will be opposite. Then that makes option number B the only correct option, colleagues. I hope this clarifies the concern colleagues had on question 1.1. That now that it is settled,
Yeah.
colleagues, or is there
Yeah,
any other?
Yeah.
Yes,
Just on what Memahola was saying, yes, she can still even use that tail-to-tail method or the parallelogram method. It still suffice, because according to that force that it is going to be applied there, it is going to come in the middle of the y component and the x component. So it is still going to give the same result. It doesn't necessarily mean always we have to go for a triangle method. We can still even go for parallelogram method. The result will be there. Thank you, Baba.
Okay. Thank you very much. Colleagues, we move on to question number 2, because we did not get any questions on other options. Moving on to question number 2.
Baba, there is a hand also there.
There is a hand. Oh, I can't see the hands. If we could help with the hands, colleagues. The person with the hand, can you please unmute and then ask your question?
Good morning, sir. It is Ingrid speaking. Sir, I just want to hear by number 1.4. The question was not clear for me in the sense of what force are they talking about? So I was scared that the learners might have a confusion regarding whether the truck is going from the road to the arrestor bed, or are you talking about the forces already when the truck was on the arrestor bed?
Which one of the
Because
following?
then, yes, because otherwise B also makes sense in terms of the force increases in the opposite direction of motion, and then the velocity also then decreases.
Which one of the following combinations in the table best describe the effect of the arrestor beds? I think we are talking about the situation where we are now in the arrestor bed, and read.
Okay, but that wasn't specified. I don't know if I'm thinking incorrectly, but that is just when me and a colleague was speaking yesterday, and that wasn't clear to us of what is the question referring to. Are they talking about the net force? Are they talking about frictional force? What is the question referring to?
Okay, but then the effect of the arrestor bed, obviously, for me, then it means the truck should be in the arrestor bed. Do we agree on that? And
Yes.
then here it is during an emergency stop. Emergency stop, obviously, it is within the arrestor bed, isn't it?
Yes.
Yes. So.
But doesn't that force then increases? Because to stop it, the force has to increase to stop the truck.
Mm. Yeah, I will still go for D because the force on the passengers of the truck and the driver, I think will then decrease. But then, yeah, maybe we can hear from other colleagues. Colleagues, what do you think?
Dr. Mohapi, thank you.
Yeah.
If you look carefully at that, the question it is in the context of momentum and the safety, like you are saying. Now, Ingrid is fine to say it's true that the force it is increasing, but what force it is increasing is actually the frictional force that it is increasing. And remember, frictional force, it is actually opposing the motion which was already going forward. So that means the velocity as it is happening, it is going to decrease. It's not going to increase. Cannot happen that way.
Yes, but I'm talking to the force that is increasing. I agree the velocity is decreasing, but my concern was with the force that is increasing and not decreasing.
Okay.
Because maybe the question was not specific as to which force.
No.
I think that is what she's talking about.
Yes.
But let's go to the context. Where are we using this? We are using it where we are saying it is a safety precaution. Because it is described under the arrestor beds are coming in that context where there should be a decrease. And yeah, we are not looking at the net force like it is in the formula, but we are looking at a specific force that it is there. Hence, we have never said forces on, maybe use the net force. We are looking at a specific force which is going to be in play here, which is going to be your friction. So that is why we are saying the friction is going to increase, but as the friction it is increasing, then for safety, then the speed it is going to decrease. Hence, we are sticking with the D, with the D.
With the D.
Yeah, we are sticking with the D. Yes.
Because we are talking of the the force on the person in context with what Ingrid with the safety considerations. I think that is the aim. In context with the safety consideration, because in any case, that is where we use the arrestor beds for safety. So that is where we are coming from. Yes, please, ma'am. Okay. Colleagues, let us move on to question number 2. Thank you very much, Ingrid, for your question. Question number 2.
I have a question.
Oh, Mr. Tiar Mukwena, yes, sir.
I just think with that question, I think I do not disagree with the structure of the question or the answer. The answer is correct, but then I think because we are teaching learners who don't have learners licenses, I think the arrestor bed alone made them to not be able or to be objective in terms of finding which force they will eventually have to choose. That is either increasing or decreasing. I think the question there on the description should have been more descriptive. Maybe have maybe a small background on what an arrestor bed is. Because I don't think any of the grade 12 learners have any idea what an arrestor bed is. For us as colleagues, as we know, most of us have been exposed into writing a learner's license. So that was just my concern, that maybe in questions like this, they are okay, but let's just be more descriptive on them, sir.
Yeah, I don't know, but I think in one of the bullets, that's a momentum in our ATP colleagues. We are there, it is specific there to say we need to make examples of the airbags and arrestor beds. I think they are there. I might be wrong, colleagues, but I think it is there. So maybe we should then make sure that we address each and every bullet that is there in the ATP. But I get what you are saying, Minia. I get what you are saying. Let us look at our ATP. Isn't that stipulated there that learners should be, or examples should be made with the arrestor beds? Mr. TR, maybe we should look at it, but it's okay. It's okay, Minir. We'll look into such things in the future. Question number 2. Yeah, the question was about the forces, colleagues. Two blocks, 10 kilogram and 15 kilogram, are attached to each other with a light inaccessible string moving over a frictionless pulley, as shown in the diagram below. Slope AB has a smooth surface and makes an angle of an angle theta with the horizontal. Then we are told that the blocks are stationary. That's question 2.1. Learners were asked to state Newton's first law of motion. Correct answer there, colleagues. A body will remain in its state of rest or motion at constant velocity unless a non-zero resultant or net force acts on it. Here, colleagues, we can apply that rule that if any of the underlined words or phrases in correct context is omitted, a learner can get 1 mark here, colleagues. So this one is not 2 or 0. We can give 1 if any of the underlined keyword or phrase is omitted. A learner can get 1 mark. But the context must be correct, colleagues. It must still make sense. It must still make scientific sense. So it will be 2 marks allocated there. And then 2.2, learners were then asked to draw a free body diagram showing all the forces acting on the 15 kilogram block. There you have your free body diagram, colleagues. You have your tension, you have your normal force and the gravitational force. But let us look at the notes. Very, very important. 1 mark. Okay. Each 1 mark. Hey. You award a mark, colleagues, if an arrow is given with a label, like T with an arrow, then it's 1 mark. Fn with an arrow, then it's 1 mark. Then Fg with an arrow is 1 mark. Can somebody please mute Matsidiso? And then that is the first point in the notes there, colleagues. For any additional force or forces, you subtract 1, colleagues. For any additional force or forces, you subtract 1. If a force or forces do not make contact with the body, then you subtract only 1, colleagues. You subtract once for each force that does not touch the body or make contact with the body. And this is very, very important as highlighted in bold, colleagues. Remember, from now onwards, we do not accept components. If your force is given at an angle or gravitational force is acting on a body that is moving on an inclined plane. So for gravitational force, if a learner gives components instead of Fg, then the learner will forfeit that mark of gravitational force, colleagues. I hope that is clear. And then the acceptable labels here, colleagues. For tension, you can accept Ft, tension if it is written in words. And then for normal force, you can accept capital letter N. You can also accept normal force. You can accept normal. For Fg, you can accept W because we have the mass of the body. You can also accept 147 newtons. Okay. And then also accept if a learner draws a force diagram. Instead of a dot, then the learner uses a block. You can accept that, colleagues. I hope 2.2 is clear. If there are any questions, colleagues will then ask after we are done with question number 2.3. Then question 2.3, learners were then asked to calculate angle theta. So let us go to the memo. Option number 1, for 10 kilogram block, if we take upwards as positive, remember the two blocks are stationary, colleagues, and the 10 kilogram block is moving vertical, or is vertical. It's not moving, it is vertical. It is hanging there, hanging vertical. So you'll start with the formula. F net is equals to MA because we are going to apply Newton's second law here. And then you say tension minus 10 multiplied by 9.8. For this part, colleagues, the whole of this, T minus for T minus 10 multiplied by 9.8 for the whole of this, then you'll get, Elena will get the mark, or you will award the mark, colleagues. And then you move on for the situation of 15 kilogram, because 15 kilogram is on an inclined plane. If you take downwards as positive for that body, you start with F net is equals to MA. Then if you say 9.8, which is the tension, the answer that you will get from here, from the first part of this calculation, you substitute it here as negative because now it will be going up the incline, and then plus FG parallel, which is 15 times 9.8 sine of theta, the whole of this substitution, colleagues, then you'll award a mark. And then for either one of the zeros here, colleagues, either one of them, if a learner has indicated this zero or that zero, then a learner will get 1 mark. And then the final mark will be of the final answer, theta being equals to 41,81 degrees. Degrees must be there, please be careful, colleagues. So theta is equals to 41.81 degrees, then that is where you'll award a mark. So let us look at this thing here, line here, colleagues. If a learner, for whatever reason, gets this 98 wrong, the answer for in this part of the calculation, if the learner gets it wrong, but then uses that answer, wrong answer, correctly in here, if this answer is wrong, but it is used correctly in here, then you will award this mark for substitution. You will award this mark for substitution, but the learner then will forfeit the mark for the final answer. I hope it is clear, colleagues. If you look at option number 2, it is just about the changes in directions. If we take up as negative, formula F net is equals to MA will get 1 mark. And then now that we have taken tension upwards as negative, then tension will be negative here, and then that gravitational force will be positive. The whole of the substitution, then 1 mark. And then moving on to the 15 kilogram block, we'll then have to take down as negative. If we take down as negative, then up the incline will be positive. Then this 98 calculated here will then be positive, and mg sine of the theta will be negative here. And for the whole of this substitution, then the learner will be awarded a mark. Remember, if a learner for whatever reason gets this tension wrong, but then this wrong answer is correctly used in here, then you can still award a mark. And then for the angle, which is the final answer, you'll then give the final mark. Or one of the zeros, remember, you'll then give a mark, colleagues. That will be it on question number 2. I see a hand from Mira. If you could unmute and then ask a question.
Good morning, sir.
Good morning.
Sir, I'm asking if a learner has written weight parallel equals to mg sine theta instead of Newton's second law formula, do we forfeit 1 mark or 2 marks because there's no formula as well as the zero is not there, but the answer is correct?
The answer, like here, the first part.
Yes, there's no F net equals to MA. Also, there's no zero acceleration. There's only weight parallel equals to mg sine theta.
Yes, but then I think we need for the learner to get to that, then the learner must have used this F net is equals to MA. But learners should not think that it is obvious for us. They need to show us, sorry, this comes from this principle. So
Yes.
that thing, that tension is equals to FG, it comes from a certain principle, and learners need to indicate that principle, which in this case, it is F net is equals to MD. Do you understand what
Yes.
I'm saying, Mine? So what
I understand very well.
yes,
But
so what we
my
will
concern
then
is
do,
that, okay.
yeah, let me finish. Ne? We can give for
Okay.
0, we can also give for this substitution, but the learner will forfeit the mark for the formula or the principle that
Okay.
he or she used to get to
Okay.
that expression of saying tension is equal to gravitational force. So I think this it is an advice to us colleagues. So learners should not assume that no teachers know or people who are going to mark know. They need to show all the steps.
All right. Thank you, sir.
Okay, thank you very much, colleagues. Is there any other question? Okay. We had something that has been coming a lot, colleagues, on question 2.3. We'll just like to address it. Here, colleagues. Coincidentally, when learners use the masses of the blocks, 10 kilogram and 15 kilogram, and then they just use the trig ratios, they get the correct answer, but this is scientifically wrong, colleagues. Remember, if we use this trig ratios, learners must use what? Must use the distances or the forces. So learners cannot use the masses with the trig ratios. It's just a coincidence. It is just a coincidence, colleagues. So if a learner uses some, I saw they were using Pythagoras theorem, some go straight to trig ratios like it is the case here, then that learner will get 0, colleagues. This one will not accept. It is 0. And let us teach our learners that trig ratios will then have to go with the distances and the forces, not the distances. I hope this settles this issue on 2.3. Okay, colleagues, I believe we can now move on to question number 3. Question number 3, momentum and impulse. Metal ball A with a mass of 750 kilograms rolls horizontally in a straight line towards a stationary metal ball B with a mass of 500 kilograms as shown below. Metal ball A travels at a constant speed of 5 meters per second before colliding with metal ball B. Due to the collision, metal ball A experiences an impulse of 6 Newton second to the left, and then the system is said to be isolated. First question
Baba.
there. Any question?
There's a hand from OV.
Pardon me, Meneer?
There is a hand from OV. I
Oh,
don't know if it's an old hand or a new hand.
okay. OV, please unmute. I take it is an old hand, Meneer. So colleagues, let us move on. Question 3.1, learners were then asked to define the term impulse. Let us go to the memo. Here, colleagues, on 3.1, we'll use part marking, colleagues. Please indicate on your memo there. For 3.1, we'll use part marking. So the first part where we will award the mark, it is that underlined part, the product of the resultant force acting on an object and the time the net force acts on an object. We will then award the marks like it is indicated there. So 3.1, this is the answer that we are expecting. That is that for question number 3.1. Colleagues, maybe you will advise, because it is not indicated here as to whether we'll accept if a learner writes impulse is equals to change in momentum. My initial feeling is that we should not accept that, but I will then be advised by my colleagues. As you are thinking about it, colleagues, let me move to question 3.2. 3.2, learners were then asked to write down the magnitude and direction of the change in momentum experienced by the metal ball B due to its collision with metal ball A. You know, during collision, colleagues, the two colliding objects will have equal magnitude of the impulse, but in opposite direction, which is the change in momentum. So correct answer there, colleagues, will be 6 kilograms meters per second, because they were asked to give the change in momentum, not impulse, change in momentum. And because the impulse on A is going to the left, then the one on B will be going to the right. So it will be 1 Mach for the magnitude, 6 kilograms meters per second, and then to the right, 1 Mach. Then question 3.3. Baba.
Yeah, 3.1 answer. Can you just maybe flag the memo?
Yeah, Baba.
Yeah, that object on the second part can be put in bracket, acting the net force acting on an object.
Okay.
Yeah, because I'm afraid if maybe a learner just leave it out, then because it's underlined, and then they can still be penalized. So maybe let's try to maybe help them also at that particular point there.
Okay. Well, what about the change in momentum, Baba? Do we accept that? Or impulse is caused to change in momentum. Do you think we will accept that? What's your feeling?
Actually, it is not a definition. It is an expression that they are trying to express whatever it is, but the question was saying they have to define. So it's still the beginning, and then we still have to use the paper to teach. So maybe for now, let's stick to the definition and not explain what the formula it is saying. So let's stick to what we have on the memo bar.
Thank you very much. Colleagues, we will not accept. I think it is the feeling of the moderator, also of the paper. So we'll not accept for changing momentum then. Question 3, calculate the velocity of metal ball B immediately after collision for 4 marks. We have 2 options, but please be aware, colleagues, that we are going to use positive marking from 3.3 for colleagues, in the benefit of colleagues who will be starting to mark this year. When we say positive marking, we mean that from 3.2, if the answer that the learner got here in 3.2 is wrong, but this wrong answer is then used correctly here, then that learner can get full marks. Let's say for whatever reason, a learner gives us 12. Maybe he or she thinks that the change in momentum will double, but the 12 is then used correctly here. You will then have to punch in the values in your calculator and check if the answer is correct according to the substitution of the learner. If everything is correct, then the learner will get full marks. So option 1, that is where we'll take right as positive. It will be 1 mark for change in momentum formula, and then 1 mark for correct substitution of change in momentum, that is 6. And then for the whole of the substitution, including the zero, colleagues, then it will be 1 mark, 0 must be substituted, please. And then the final answer together with the direction, final answer together with direction, then you'll get 1 mark, or Elena will get 1 mark. Option number 2, change in momentum formula, then Elena will get 1 mark. But now that we have taken left as positive, then this answer from 3.2 will be negative. Then there will be a mark there. Please indicate that mark there. I can see that it is missing. Please indicate that mark. And for the substitution on the right-hand side, whole substitution together with that 0, colleagues, then it's 1 mark. And then we do not mark here where the learner will get a negative answer, but we'll mark at the final answer, which is 12 meters per second to the right, NAREX. Then answer plus direction will be 1 mark. Okay, colleagues. Remember, we'll take questions at the end of the...
Now question.
Can I take them at the end of the question, please?
Okay.
Now moving on to question number 3.4. After collision with metal ball A, metal ball B collides with another metal ball C with a mass of 900 grams, which is traveling at 10 meters per second to the left. Metal ball B moves at 2 meters per second to the left after collision. Then learners were then asked to explain what is meant by the term isolated. Then here colleagues will give 2 or 0. We'll give 2 or 0 here. A system on which the net external force is 0. A system on which the net external force is 0. This one, a learner can get 2 or 0. Please indicate there on your memo, colleagues. And then the next question, 3.5, calculate the speed of metal ball C after collision. The speed of metal ball C after collision, the learner will then apply principle of conservation of linear momentum, but taking using positive marking from question 3.3 where we got 12. And then it will be first option will be where we take right as positive. The principle of conservation of linear momentum, 1 mark. Whole substitution on the left-hand side, that is your initial part, 0.5 multiplied by 12 plus 0.9 multiplied by -10. All of that, 1 mark. On the right-hand side, 0.5 multiplied by -2 plus 0.9 multiplied by VFC. All of that, 1 mark. And conclusion, or rather, final answer, colleagues, speed, because here we are asked for speed. Speed will then be equal to 2.22 meters per second. Then we need this one. Okay, option number 2. Here we are taking left as positive. Principle, sigma pi is equal to sigma pf, 1 mark. Substitution on the left-hand side, it will be 0.5 multiplied by -12 plus 0.9 multiplied by 10. The whole of that substitution, 1 mark. And then on the right-hand side, 0.5 multiplied by +2 plus 0.9 VFC. The whole of that substitution, 1 mark. And the learner has to write speed is equals to 2.22 meters per second. Remember here we are calculating in this formula, colleagues, we are dealing with vectors. So the first answer that the learner gets there is a vector actual. So the learners, if asked to calculate the speed, they need to conclude and say speed is equals to this. They shouldn't leave it here because these things that we have here are vectors and speed is a scalar. So speed will then be equals to 2.22 meters per second. Then moving on to 3.6. Learners were then asked to prove whether the collision between the metal ball A and metal ball C is elastic or inelastic. They must use a calculation. Here, colleagues, in 3.6, we'll take positive marking from question 3.3 and 3.5. Remember, we said with with positive marking, if the learner got the answer wrong in 3.3 and 3.5, but then the learner uses the wrong answers that he or she got in 3.3 and 3.5 correctly here in 3.6, then we'll award full marks, provided that the learner has done correct calculations. You'll then have to punch in those wrong values of the learner, colleagues, and then check if the answer is correct according to his or her wrong answers. So to prove whether collision is elastic or inelastic, colleagues, we know we'll then have to calculate total kinetic energy before and total kinetic energy after. I can see a mistake here. Please remove this F here. It should be I. So sigma Ki will be equals to the formula there. You add all the kinetic energies before collision, and then 1 mark for that formula. It can be here or on that formula for final kinetic energy. And then for correct substitution, all of the substitution, colleagues, everything must be there. And please be careful of the squares. Learners sometimes they forget the squares. So 1 mark if everything is substituted correctly, like it is the case there. And then the 3rd mark will be on the substitution on the total kinetic energy after collision. If everything is substituted correctly, not forgetting to apply positive marking, colleagues, then 1 mark for correct substitution, and then comparison of total kinetic energy before and total kinetic energy after that they are not equal will be 1 mark, and then conclusion that the collision is inelastic will be 1 mark. If a learner starts by equating the two, then the learner can get a maximum of what? Of 3 out of 5. It will be substitution for both of them, comparison that they are not equal, and then that the collision is inelastic. That is where we'll give the mark, colleagues. But this is actually wrong, colleagues. This is actually wrong. We are being lenient here. This is not how a learner should start his proof of whether the collision is elastic or inelastic. We are just being lenient here, colleagues. So if a learner starts here, then you can give 3 marks substitution for both of them. And then where the learner then writes that total kinetic energy before is not equals to total kinetic energy after, then the learner will get 1 mark. And the collision is inelastic, then the learner will get that 3rd mark. And that will be it on question number 3. I have some notes on question number 3. Before maybe colleagues come with their questions, maybe I should just show colleagues notes on question number 3, just for them to note. Maybe the notes will then respond to the questions that they might be heavy. Let us look at the notes, colleagues, before you come up with your questions. So for 3.3, colleagues, we can accept this formula because it was not specified that learners should use only change in momenta. If a learner uses impulse formula, then you'll give a 1 mark there, and then 1 mark for substitution and 1 mark for substitution like we have done there, and then 1 mark here. Award full marks if a learner takes this approach, colleagues. And then I believe we have another one, if I'm not mistaken. No, we don't. No, we don't. No, we don't. That will be it on question number 3. I saw maybe about 2 hands, colleagues. If you can unmute and then ask your questions.
Sir, I have 3 questions. The first question is on 3.3. What if a learner uses momentum formula instead of changing momentum formula, knowing that the initial momentum of B is 0? Hello? Sir, are you with me? Sir, are you with me?
Yeah, I think Mr. Mohatu will just join you. Yeah, we'll be joining you.
Hello, Minnie.
Sir, I was saying on question 3.3, What if a learner uses the formula for momentum instead of using the formula for change in momentum, knowing that the initial momentum of B is 0?
When it goes back to what I said earlier, that learners assume that we know, like the teacher, like
Yes.
they assume that we know. That's my problem with our learners. You see?
So do I give the learner 0 because the answer is correct?
Yeah, the answer will be correct.
So how much should I award
Yeah,
to learners?
trying to figure it out. Colleagues, what do you think? My thing will be maybe we subtract 1 mark for the formula, and then yeah, let us subtract 1 in that case.
TV,
Yes, Menir.
TV.
Okay,
Can I come in?
I get the point. I will subtract 1. And then another question is that on the same
Just
question.
Before you move, Menir.
Wait, before you move,
Wait,
Lilian,
before you move.
can we go back to that question that you raised? The learner is giving us the momentum instead of the change in momentum. Now, the 6, it is a change in momentum. So he is saying the momentum is 6 and not the change in momentum. And it is a wrong principle that it is being applied here. Even though the answer is correct, but the principle is wrong. Change in momentum will never be the same as a momentum itself. So he's substituting something irrelevant here. So to give 1 mark, I still think it is generous because the learner actually is not using the right principle to go to the correct answer. Like I indicated earlier, colleagues, let's try our best to help these learners. It's still very early in the year. Let's give them the correct physics so that it is come the end of the year, we are not going to be surprised with whatever we are going to get. The results are for now, and the memo discussion, the aim, it is also to get rid of the misconceptions that these learners are doing. Once we give them marks at this point for wrong things, they will continuously get marks for the wrong things. So my take is the learner doesn't understand the change in momentum and the momentum itself. And then we are going to do the same. If ever we are going to work energy theorem for the change in kinetic energy, are we still going to accept it as a kinetic energy only? It's a wrong principle. We cannot do that, colleagues.
All right, I hear you. You see, the premise that Menir put that the learner knows that the final momentum, the initial momentum is 0. I think that, but I think we should not give, now that Ntate has explained, Menir. Yeah, man.
Yeah,
No, let us be strict now that it is the beginning of the year, Menir.
Yeah. The other
Let us
thing
be strict.
the other thing, it's about us. Not when we mark, we have to mark what the learner is presenting to you. We don't have to please assume that this learner is intending to say this. We don't know what was in the mind of the learner, so we cannot judge for the learner at that particular point.
Okay.
So I get you. So in that case, I'm supposed to give 1 mark to a learner or 0?
Yeah, give 0, Menir.
0. Okay,
Yes.
thank you. And then another question is on 3.3 again. What if a learner uses conservation of linear momentum formula instead of using the change in momentum formula?
Okay. So what are you saying? Are you saying that the learner will then have to calculate the final velocity of the object?
Yes. The learner used conservation of linear momentum formula because they have V initial of A, and then, sorry, I'm not sure. Do we have V final of A? I'm not sure about that.
Yeah, let us check. So for B, they can use this to calculate. I don't think it will work. We have initial velocity. Oh, it can. We have final initial velocity of A. We can calculate with this.
Final velocity of A.
We can find final velocity of A because we have the impulse of A. And then we can also, with the answer that we got here, find final velocity of B. And then, yeah, I think it can work, yeah.
Okay, thank you, sir.
Okay.
Then the last
So
question.
in that case, then we can give full marks. Yes, I think it can work. Yes.
Yes.
Mhm.
My last question is on 3.4.
Okay.
If a learner had written only the net force equals to 0, they didn't specify that it's a system where the net force equals to 0. The learner just said the net force equals to 0.
Mm. Yeah, but
Because in my mind is that on the question already we have a system.
we have a
They were
system,
asking
yeah.
what is an isolated system. So the
Mm.
learner was responding, what is an isolated system? But the learner just wrote the net force equals to 0. So I'm not sure if I should award marks or not.
Yeah, I think yeah. Let's award the minimum. Yeah.
Okay, thank you very much, sir.
Thank you. Any other question, colleagues?
All right.
Memahula. Oh.
Okay,
Memahula.
yes,
Okay.
regarding the previous question, 3.3,
Mhm.
when I check the V final of metal A, it says it's 13, and the learner did not show on the calculations that he got 13 meters per second. I only saw it when he's using the change in momentum, I mean the total linear momentum, where sigma P before is equal to sigma P after. Then I see the 13 there. Do I award full marks, or what is it that I can do now?
Then where does the 13 come from?
It's
So
not there, it's not indicated.
It's not calculated.
I think the learner calculated aside, because when I calculate the V final of board A, it's
It
13
is
meters per second.
okay.
Yes.
And then now the learner uses that 13 in the
Yes.
principle of conservation of linear momentum.
Yes, and then he got the correct answer.
He got the correct answer.
Yes.
Yeah, no, yeah, let us give a benefit there. It's fine. Okay. Was it that it Tunzi?
I'm happy.
Yes, ma'am.
All right. Just clarity on 3.4 and the last question on proving elasticity. And I'm happy. We have these learners who are saying there it's a system where there are no external forces. Would that be considered, or would we just stick to exam guideline as it is?
We stick to exam guideline. It is 0.
Okay. And then lastly, thank you, sir. And then the last one on proving whether it's elastic or inelastic. Now, these learners are using values that are unknown. For example, there's a 0, which it's not understood where it's coming from for a velocity. But now, of course, they are not getting their sum of EK final. I mean, they get different values for sum of final kinetic and sum of initial kinetic. They are different, and they do write the inequality that they are not equal, and then it's inelastic. Would such a learner get 3 marks, or would they not get? Would they just get for a formula?
Okay. No, I think we'll give 3 minutes. Then the learner will forfeit for substitutions. Will not get marks for substitutions.
Okay, thank you, Dr. Kelly.
Thank you. Can we move on to question 4, colleagues? I do not see any. Oh, there is a hand.
Hello.
Yeah, there are quite a number. There is TR, there is Cry, if we can maybe get them, TR Mukwena, and then I'll come back. And there is also Kali, if we can get the 3, and then I'll come in.
Okay.
Yes, ma'am. Yes, ma'am. It's TR.
TR.
Yeah. Yes, ma'am. On 3.5, ma'am, I have a learner who used the change in momentum of B is equal to the negative change in momentum of C. And then applying that, they get the same answer. So I awarded full marks. So I was thinking maybe if we can add that as an option as well.
As an option, yes. Thank you very much. Yeah. Though we do not encourage it, but then, yeah, it leads to a correct answer. Yes. Because in any case, we know the two, when they collide, they will have equal change in momentums, but in opposite directions, which is correct. Any person?
Yes, sir.
Yes, meaning.
Maybe please go back to question 3.3.
Okay.
Regarding the usage of the formula of principle of conservation of linear momentum, where Lena used the formula sum of momentum before equal to sum of momentum after. And then I heard you saying that they should not be given full marks, they should be deducted 1 mark.
No, I did not. I did not mean it. I said you can give
full marks.
Yes.
Okay, sir. Thank you.
Yes, yes. But everything must be correct. If I had to make correct, she said that the final velocity of A will be 13 or something. So if that thing is correct, if everything is correct, then yes, you can award me. Just confirm the final velocity of A for us.
The final velocity is 12 meters per second and to the right.
Of A?
Yes.
Okay, of B?
Of B, sir.
Of B, yes. Of A is how much? Should be 13 if I had to make correct there.
Of A.
You can confirm it, colleagues. Just confirm if the final velocity is 13 and then it works out correctly to the final velocity that we are looking for of 12. Yeah. Okay. In the meantime, whilst Minir is busy, the following person, next person.
Hello, Ntate.
Yes, ma'am.
Hello. Yes,
yes, ma'am. I
I
can hear you. Yeah.
Yes, for 3.6, Elena did not forget to substitute the squared in one of his substitutions, but the answers are correct. Will the learner forfeit those 2 marks of substitution?
Of substitution, yes.
Even though the answers are correct.
Yes, we'll forfeit. Because we don't mark the answer, we mark the substitution there. Substitution must have a square. Yes, the learner will forfeit the 2 marks. Even though the answer, which means that on the calculator, the learner did the correct thing, but then it did not show that. So yes, the learner will forfeit me the 2 marks, but then we'll get a mark for the formula, then the inequality of the kinetic energies, and that conclusion that collision is inelastic. Give 3 me.
Thank you.
Thank you. Are we done? I didn't see anyone who can see the hands. Are we okay?
There is Albert and then there is Mpumelelo. Then I'll come in.
All right. Albert?
I already asked the question.
All right.
Yes.
Can you lower your hand, Miniri, please? Mpumelelo?
There is Mpumelelo.
Oh, okay. Morning, colleagues. My question is on question 3.6. Regarding that positive marking from 3.3 and 3.5. So I just want to confirm with you here, Melia, that so it's possible that Elena can get full marks, although they got those few answers incorrect.
Yes.
Oh, okay.
It is possible. Like 3.3, what was the answer? It is 12. Ne? If that 12 is substituted correctly,
I think the learner substituted the incorrect answer correctly in that to prove that the collision is inelastic. I think that they substituted correctly. However, the answer is not the same as what is in the memorandum. However, I've noted that here we are marking only the principle as well as the first substitution and the second one, as well as the conclusion.
So yes,
it's possible that
yes, if the answers are taken from 3.3 and 3.5, if they are from there, they shouldn't be from anywhere. If they are from 3.3 and 3.5 and correctly substituted here, then you can award the marks. Yes, Minnie.
Okay, then in a case where, say, the learner took those answers, okay, no, I get it. Okay, no, it's fine, man. Thank you.
Okay. Are we done with the hands, Minir? Now I can't see from my side.
Okay, yes, Baba. If Mbugana can lower the hand, and then we're having Kele Bahale, Matripe Fenter, if they can also lower their hands, because I see their hands are still up if they don't have questions. Baba, can we go back to question 3.3? I just want to make a comment on the memo.
Okay.
For the second substitution. Colleagues, in this part, if the V final and the 0 are swapped, that means it is going to be a wrong substitution because V final, it is not 0. All right. Now that will be saying to us, therefore, the answer because of the wrong substitution, even though it is going to be correct, we are going to mark it wrong because it's a wrong substitution. And that learner must get 2 out of 4. That is the comment.
Okay. Yeah, that is clear. Thank you very much, Baba. I believe, colleagues, we are done with question 3. We now move on to question 4. Vertical projectile motion. A helicopter picks up a package through a cord from the ground shown below. The package is then pulled up at constant velocity of 10 meters per second. Then 4.1, learners were then asked if the package can be considered a projectile while being pulled up. The correct answer there, colleagues, should be a no. While being pulled up, the answer should be a no. And then the next question, 4.2, for 1 mark, give a reason for your answer to question 4.1. Then the reason will be gravitational force is not the only force acting on the package. Gravitational force is not the only force acting on the package, or there are other forces other than gravitational force acting on the package, because projectile is related to gravitational force. So the learner must say something about gravitational force, and then you'll then have to look their colleagues or now. Is it in correct context now? And then you give a mark. But the learner must say something about gravitational force because projectile, we somehow related to gravitational force. And then next question. When a package reaches a certain height h, the cord breaks and the package undergo free fall. The motion of the package after the cord breaks until it hits the ground is represented through a velocity versus time graph there. Then the first question is define the term free fall. So here learners were asked to define free fall. If a learner does not have motion, colleagues, if a learner sees an object, then it should be 0, colleagues. This one, it must be 2 or 0. 2 or 0. If the underlined weights are not there, colleagues, if any of the underlined weights are not there, then we give 0, colleagues. It is a simple definition, colleagues. Our learners must be able to state this one. Motion during which the only force acting on an object is gravitational force. So let us not use context here. Let us say all the underlined weights must be there. Then 4.4. 4.4, sorry. Write down the following. VI, that is the initial velocity of the object when the cord broke. Initial velocity will obviously be the velocity at which the helicopter was moving with. That is 10 meters per second, 1 Mach. Then magnitude and direction of the acceleration of the package at time t, that is at the maximum height. We know now that it is undergoing free fall, then its acceleration will be 9.8 meters per second squared, 1 Mach, and then downwards, 1 Mach. 9 meters per second squared, 1 Mach, and then downwards, 1 Mach. So they are marked independently like that. Next question, that is 4.5. Learners were then asked to calculate 4.5.1 times t, time it took the package to reach its maximum height. So we'll use the first formula of the equations of motion. You know it is going to the maximum height. Then we say Vf is equals to Vi plus A delta t. Final velocity at the maximum height will be 0. Initial velocity it is 10, taking upwards as positive, and then negative 9.8 delta t. Then t will be equals to 1,02 seconds. If they take upwards as negative, we can accept it. As negative, we can accept it, though on the graph, it is clear that upwards was taken as positive, but let us accept if up is taken as negative. If that is the case, then initial velocity will be negative and your gravitational acceleration will be positive. Then the answer should go, the learner should get the same answer, t is equals to 1,02 seconds. Then the next question, learners were then asked to calculate the speed the package hits the ground with. The speed, colleagues, very, very important. In the equations of motion, remember we are dealing with vectors. Then the learner has to conclude and say speed is equals to this. So we'll take positive marking from 4.5.1 of the time. And then here we'll then say option number 1, taking upwards as positive. Vf is equals to Vi, and then 18. It will be 10, which is the initial velocity. And then taking upwards as positive, G will be negative 9.8, and then multiplied by 8, then the learner will get negative 68.4 meters per second. And then the learner has to write speed is equals to 68.4 meters per second. Option 2 is just the change in direction. Up is negative, then 10 will be negative, and 9.8 will be positive. Then it will still lead to the same answer. And then option number 3, the difference here is where we take our motion from. Option number 3, it is when a learner takes the motion from the maximum height to the ground. We know if the learner takes the motion from maximum height to the ground, then initial velocity at the maximum height is 0, negative 9.8 multiplied by the difference. Yeah, 8 and 1,02, which is the time it took the package to get to the maximum height. And then the answer should be 68.4 meters per second. This is when a motion is taken from the maximum height to the ground. Option 4 is just the change in direction there. Initial velocity will be 0, and then 9.8 will be positive, and then 8 minus 1.02, and then the answer for speed, 68.4. And then option 5, it is when a learner now takes the motion from the height where the object was, or rather the cord was broke, but now the object is moving downwards. From that point where the cord broke, but now the object is going downwards, the initial velocity will be the same, but in opposite direction, because now it is a downward velocity. And then we know that the time will be, to get to that point, will be twice the time it took the package to get to the maximum height. So the answer, the substitution, we expect the negative 10 plus negative 9.8 multiplied by 8 minus 2.04, which is twice 1.02. Then the answer in this case will be 68.408, and the speed there, it is that, colleagues. If we change direction and take up as negative, that 10 will be positive, 9.8 will be positive, and the answer will be the same as in option number 5. And please accept option number 5 and option number 6, because it depends on now where the learner takes the motion from. That is that on 5.4.2. We can now, colleagues, move on to 5.5. 4.5.3. Learners were then asked to calculate the displacement, the package covered in the last 2 seconds of its fall for 6 marks. Here, colleagues, the principle of positive marking will be applied. We take that from question number 4.4.1 and 4.5.2. I take it even the new colleagues now understand how we apply positive marking. First, learners will then can calculate the velocity with this option 1 that we have here, colleagues. Learners can calculate the velocity when the package has traveled for 6 seconds. That will be velocity after 6 seconds. 48.8 is velocity after 6 seconds. With this velocity, then a learner has several options to take. You can use this formula. VF squared is equals to VI plus 2A delta Y. And then from 4.5.2 final velocity, it is the ground width will be substituted there. And then velocity at 6 seconds, but now it will be an initial velocity because we are covering the last 2 seconds. This velocity at 6 seconds will be an initial velocity if we are moving from 6 seconds to 8 seconds. So initial velocity 48.8 squared plus 2 into negative 9.8 times delta y. And then you'll have your displacement as negative 117.2 meters, and then the learner will conclude that the displacement in the last 2 seconds will be 117.2 meters, and then down. So you'll mark the magnitude with unit and then direction. That is the first route that the learner can take after calculating velocity at 6 seconds. And the second route that the learner can take is where you use the third formula from the equations of motion. Initial velocity, because now we are covering only the 2 seconds, the last 2 seconds. So initial velocity will be that velocity at 6 seconds, 48.8 multiplied by 2 plus half into 9.8 and then 2 seconds. Then the learner will still get 117, negative 117 because we are going down here, 117.2 meters per second. And then the learner will then conclude to say displacement is 117 meters. 0.2 meters, then a mark for the magnitude and a mark for direction. Another route that the learner can take is where you use this fourth formula. Initial velocity at 2 seconds. It is 48.8 final velocity, which is at yes, in the last 2 seconds, this is the initial velocity that is at 6 seconds, and then this will be the final velocity at 8 seconds. And then for substitution in the bracket, the whole of the substitution in the bracket there, you can give 2 marks, and the substitution of 2 will be 1 mark, and the final answer of displacement there. And a learner can opt to use the area under the graph. A learner can opt to use the area under the graph as you look at that graph of hours in the last 2 seconds. Graph of hours in the last 2 seconds, let's say we are having 6 somewhere here, colleagues, I hope you can see. If 6 it is somewhere here, and then you draw a line here, you can see that the shape that we have under the graph there, between the graph and the time axis, it is a trapezium. So we can accept that as an option. If that is the case, we'll have the formula of trapezium, 1 mark. Some learners will then prefer to say an area of a triangle plus area of triangle plus area of the square or rectangle. You can accept that also. So substitution on the first part of the A in the formula, 2 marks, substitution of the 2 for H, and then conclusion there. So that will be that for option number 1, colleagues. And then option number 2 is about the changes in direction only. It is about the changes in direction, basically. Now we have taken up as negative, Everything that I've said, colleagues, still applies here. The only difference is the changes in direction. Like you'll see here, your turn will now be negative and your acceleration will be 9.8. I do not think, colleagues, for the sake of time, we'll then have to go through each and every option here. Let us try and save time. It is the change in direction only, colleagues. We received few options that are not indicated in the graph that we can accept, colleagues, for 4.5.3. So here the learner can calculate the displacement or delta H. If the learner calculate delta H, because the initial velocity here, as you can see, it is 10, meaning it is the initial velocity. And the final velocity, it is the one that we have calculated there. Then the learner will get height H being equals to this. It's fine. Then the learner goes on to calculate height up until 6 seconds. Initial velocity is 10 to 6 seconds. They say 8 minus 2, and then they get their displacement being this, and then they subtract the two displacements, and then they will get 117.2 meters. We can accept this option, colleagues. If you come across this option, it is correct. Please accept this if you find it. But the hint will always be, if the answer is correct, colleagues, most probably the learner has done everything correct. Just try and analyze the answer that the learner gave. And then I think we have another option that we were given here. It is this one. It's more or less like the one that we have explained. Yeah, it is the same as the one that I have explained. But the difference is that the learner uses the third formula in both cases, but it is still the same as that one, colleagues. Please accept it. That will be that on question number 4.5.3. Then 4.6, learners were asked to draw a displacement time graph for the motion of the package from the moment the cord breaks until it reaches the ground. And learners in capital letter were told to take ground as the reference point. These are the important things that the learner must indicate on the aircraft. One, height H, time T, which is the time it took the package to reach the maximum height, and then the time the package reaches the ground, which is 8 seconds. So this is the shape of the graph that we expect our learners to draw, taking ground as the reference point with up positive. This is how our graph should look like. And then we look at the marking criteria, or if down is taken as positive or up is taken as negative, then this is how your graph will look like. Let us look at the marking criteria. If height H is correctly indicated, you award a mark, colleagues. Please follow this criteria. If height H is correctly indicated there, then award a mark. Time T is correctly indicated, time it took the package to reach the maximum height. If this is correctly indicated and goes with the maximum height, then you can award a mark. And then 8 seconds, time the package reaches the ground, correctly indicated. Also there, 8, this is where the motion of the object ends. 8 correctly indicated, you can give a mark. And correct reference point used, ground is used correctly as the reference point, then that will be 1 mark. And the shape of the graph, colleagues, then Elena will get 1 mark. And that will be where the 5 marks on the graph will come from. And then if ground is not used as the reference point, then you subtract 1 mark. Maybe the graph or the learner's graph starts at height H like this. You have your time axis here, colleagues. If this is the case, but everything else is correct, then you can award 4 out of 5. If point of projection or the time where the cord broke is taken, or the point where the cord broke is taken as the reference point, then you can give 4 out of 5, not 5 out of 5. That will be that on question number 4. I will open this. I will open now, colleagues, for clarity seeking questions on question number 4. As you help me, Baba, or anyone with the hand.
Okay.
From, yes.
Let's start with Metimatsu. Metimatsu.
Right. Thank you. Yeah, thank you. Going back to question 4.2, where the learner was asked to give a reason for the answer 4.1. Okay, the learner didn't actually say anything about the correct false. Instead, the learner explained for the projectile, the object, is not experiencing a free fall. So should we award a mark for that?
No. No, Minion. You see, that is the learner then expects us to know what does free fall mean. You see, they are introducing another term to us. Let us be careful. Learners must be explicit in their definitions, colleagues, please.
All right. No, that was all. Thank you.
Thank you.
Mira. Mira. Okay, Mira is not. Mukwena TR. Mukwena TR. Not there. Can you go to Lesono? Lesono Mohammed.
Okay, good sir. Yes, I can. Can you hear me loudly?
Yes, proceed, that we can hear you.
Okay, when it comes to question 4.2, what if the learner decided to explain that it will also be part of the forces acting, but not including the force of gravity?
No, meaning projectile must be related to gravitational force, please.
Okay.
So gravitational force must be
Okay,
mentioned, please, meaning. Yeah.
Okay, I'll note that one. And then when it comes to the graph, what if the learner did not decide to use the graph with H and T, but decided to use actual values, meaning they have calculated everything that was needed as part of the graph?
Yeah, especially for T. T is 1,02, ne?
Yes.
Yes, yeah, we can award that, but then 8 must be 8. The height, maybe the learner used an option with the height.
Yes, instead of H, he gave me the height at which the ball was started being projected. Yes.
And I think that value should be 233,6, ne?
Yes.
What is that value? It has to be 233,6.
Yes, it.
Yeah.
And then the maximum height was 238.7.
Okay, yes. Yeah, we can accept meaning. Thank you. Okay.
Okay, thank you.
Thank you. Any other question?
Baba, okay. Can you go to question 453 on the trapezium, on the memo?
Okay. There you go, Baba.
Yeah. That substitution marks there, I think there are more ticks there. Because one mark, remember, it is coming from the top there where they were calculating that 48.8. So if we take all that mark plus this, makes this total to be 7. So maybe we should remove one tick there.
Okay, I think even here, ne?
Yeah, even the other, even
this
where we are
side.
having a delta, even
Yeah.
where we are having the delta Y,
Okay.
also there are more ticks there. If you can
Yeah,
just maybe remove one tick on each.
Yeah. No, thank you. Thank you.
No, that's fine.
Okay. No, thank you very much, Bob. I take it already. We do not have any questions, colleagues. We move on to question 5. No questions, Baba, ne?
No, there are no questions. If Mira and maybe Mr. Mohali, they can lower their hands.
Okay.
Oh, sorry. No,
There's a question in the chat, William.
There's a question in the chat.
Sorry, I actually have a question.
Okay, can you put the question? Yeah, just put your question now that it is your mic is on.
Okay,
Yeah,
so for question 4.4.1 and also.
Okay, 4.4.1.
Okay, the learner gave me the velocity as 10 meters per second, which is okay. And then for 4.4.2, instead of writing 9.8 meters per second squared down, they chose to write negative 9.8. So should I give a mark for the negative, meaning it shows they chose up as positive and then down as negative, or should we write down in words?
Yeah, it should be down in weights. Don't give me name. Anyways, the final answers must be positive. Don't give me name.
Sorry.
Yes. Lape, we should not assume that the learner says down is positive.
So should I take the negative, or we need those words down?
Yes, we need that weight down, Minia, for direction. Yes. We need that weight down, Minia. We don't need negative to tell us yes.
Yeah, I think also the colleagues, the question was explicit that it should be magnitude and direction. So it should be explicit. And colleagues, can we put the message to our learners that wherever we want the magnitude is an absolute value, and absolute values are always positive. It cannot be negative. So that negative, you cannot award a mark for it.
Okay. Someone was reading a question from the chat. I don't know whom it is, but sounded like
Yes,
TR.
Yeah, there's a colleague who said, I just want to know at question 2, in the question, it is not mentioned that the movement is constant or that there is no acceleration. How is they supposed to know, or I think we wanted to, how are they supposed to know the net force is 0 or the acceleration is 0?
But in the question paper, there it was stated that the blocks are stationary.
Yeah, I mentioned it, but then he then said the question said inextensible string moving over a frictionless pulley. I wanted to respond, but I reserved my question.
Oh, you wanted to respond, but it is the string that is moving there. It is not the blocks, yes. Yeah.
I think the colleague is listening.
Okay, thank you. But it is understandable, I hope, from your side, yes.
Because I think it's just the matter of moving over and passing over is one and the same thing. It doesn't necessarily mean that the objects are moving.
Yes, Mina, yes. Yes, Mina, thank you very much. Thank you. I take it we are okay now, colleagues. We move on to question 5.
No, just lower your hand, please.
Question 5. Now we move on to organic chemistry, colleagues. Question 5 was on the naming of organic molecules. The letters A to D represent 4 organic compounds from different homologous series. And then the first question, we have the 4 there, A, B, C, and D. 5.1, then learners were asked to define the term homologous series. Homologous series, colleagues, we expect learners to define it as a series of organic compounds that can be described by the same general formula. A series of organic compounds that can be described by the same general formula, or a series of organic compounds in which one member, a series of organic compounds, it must start there, this or part, colleagues, must start from a series of organic compounds in which one member differs from the next with CH2 group. Here, colleagues, will apply 2 or 0. All the underlined weights must be there.
Can I quickly ask Minil?
Am I being harsh?
No, Minil. It's just that something else different that I came across, so I was a bit skeptical.
No, it's fine. We'll deal with the questions. Let me finish it.
All right.
All right. Now 5.2. 5.2.1, learners were asked to name the homologous series to which compound B belongs. That is the aldehydes, colleagues, 1 mark. 5.2.2, name the functional group of compound A. Compound A is an alkyne. Then the name of the functional group will be triple bond or carbon to carbon, triple bond, but carbon to carbon we can put in brackets. Carbon to carbon, triple bond, can put carbon to carbon in bracket. And then 5.2.3, letter representing the unsaturated hydrocarbon. It can be A or C. A or C, then we can accept that, colleagues. Then 5.3.1, learners were then asked to write down the IUPAC name of compound A. IUPAC name of compound A. The name of compound A is 5,6 hyphen dimethyl hept hyphen 2 hyphen wine. That is how I say them, colleagues, so that these learners will remember already. The hyphens are important. Or 5,6 hyphen dimethyl hyphen 2 hyphen heptyl. How do we mark this name, colleagues? We have a criteria there. For heptyne with the position of the alkyne, of the triple bond, that is 2, then Elena will get a mark. If Elena writes hept hyphen 2 hyphen wine or 2 hyphen heptyne, Elena can get a mark for that parent name. The other mark can be awarded if a learner writes dimethyl. If a learner writes dimethyl, indicates the dimethyl, then a learner can get a mark. And then the final mark will be given if the whole name is correct. Will be given, that final mark will be given if the whole name is correct, colleagues. Meaning, if the learner just write hept 2 wine, then the learner can get 1 mark. If the learner indicates dimethyl, then the learner can get 1 mark. And then if the whole name is correct, obviously, these 2 must be correct for the whole name to be correct. And then the learner will get the final mark there, colleagues. I hope it is clear, 5.3.1. You look for the parent name. If it is correct, 1. Dimethyl is there, 1. And if everything is correct, 1. Okay. And then 5.3.2, learners were then asked to write the IUPAC name of the functional isomer of compound B. Compound B is an aldehyde, colleagues. So its functional isomer must be a ketone, but a ketone with how many carbon atoms? A ketone with 4 carbon atoms. So a ketone with 4 carbon atoms will be butanone or 2-butanone or butane. Please be careful. Some learners will write but and then write hyphen 2 hyphen on. Just be careful. If the learner goes for that, then just be careful that the AN is there. So if the learner writes that, then the learner can get 2 marks. He can accept if the learner does not indicate position of the carbonyl group in this case, only for butanone, colleagues, and propanone, I think, because there's only one possibility of the position for the functional group. Then we can accept 2 marks if the position is not indicated. And even if it is indicated, let us accept, colleagues. Let us accept, colleagues. And then the next question, 5.4, learners were then asked to write down the structural formula of 5.4.1, the functional group of the functional isomer of compound D, functional group of the functional isomer of compound D. Compound D is an ester. The functional isomer of an ester is carboxylic acid. So actually here, learners were asked to write the functional, the structural formula of the functional group of carboxylic acid. So everything must be correct here, colleagues. Then if a learner gives everything correct, then the learner can get 2 marks here. Next question. Learners were asked to write down the structural formula of compound D. Let us look at compound D, colleagues. It is an ester. The marking criteria is there. If the functional group is correct, it is encircled, the functional group is encircled, colleagues. You start first by marking the functional group. In fact, encircle the functional group, colleagues. If the functional group is correct, then you give 1 mark. And then if the whole structure is correct, then you give 1 mark. All the hydrogens must be there, colleagues. Please just be careful that the learner includes all the hydrogens. And the bonds, all of them must be shown because we are dealing with a structural formula. Next question. A straight chain isomer of compound C. Compound C is an alkene. Then we want a straight chain isomer of compound C. How many carbons do we expect there? Is 5. Then this is pentene, colleagues. And then you can have this or that. This is just but a change in the position of the double bond. So if a learner writes with a double bond at carbon 1, you can give 2 marks. If a learner writes or gives a structure with a double bond at carbon 2, you can still give 1 mark. It is fine. So marking criteria, you look for the functional group first, colleagues. If you have the functional group for alkenes, 1 mark. If then the whole structure is correct, then you give the next mark. I hope that is clear, colleagues. That will be it for question number 5. We'll then open for questions on question number 5. I believe everything was clear here, but then we'll open for questions, colleagues.
Yes, Mini.
Yes, TR.
Yes, Mini. I wanted to find out, there's a learner who did something that I did not teach. Now, this learner, by defining homologous series, they wrote organic molecules or a series of organic compounds that share the same general formula or functional group. So I don't know whether I should award 2 marks.
That share the same general formula and functional group. Yeah. Though it does not come from the examination guideline, but it sounds correct. It sounds correct.
Yeah,
I'll give
correction.
But then just caution them. Just caution them, or they must give definitions as they appear in the examination guideline. But it sounds correct, yes. Any other question, colleagues?
Sir, I have a question on 5.4.1.
5.4.1.
Yes. The question was asking for a functional group. But what if a learner through an isomer of compound B instead of the compound D, a functional isomer of compound D instead of only the functional group?
Wrong. It is wrong. 0 meaning.
Yes. Okay. Sharp.
Any other question? Yes.
Yes. For 5.3.1, if a learner wrote 5.3.1.
Okay.
Yes. If Elena wrote everything there for IUPAC name except the position of the triple bond, indicating the position of the triple bond, how much should Elena get? 1 out of 3 or 2 out of 3?
It will be 1 because I get the first part, this first mark of hept 2 wine, then the learner did not indicate the position. Ne?
Yes.
Then the learner loses that mark, but dimethyl is there. Ne?
Mm.
Then the learner gets the mark, but is the whole name correct? No.
Mm.
Then it means the learner will get 1 for dimethyl.
Okay, good.
Okay, ma'am. Do we have other questions, colleagues? Yes, ma'am. Got it.
Yes, it's 5.4.1. The learner decide to put R on the left of that structure.
Yeah. Which book is this learner using now? Those are the old books. Yeah, no, I think we can give Memo, it's fine.
Thank you.
Yes. Yeah, colleagues, let us keep up with times, please. Let us give learners the updated information. Yes.
The question, the previous teacher.
Yes, see what you are saying here. You see on the here. I think you can see, ne? The learner then puts an R. Instead of leaving it out like this, then the learner puts an R. I think that is what was used previously, long ago. Do you get it, me?
Yes, thank you, Ntate.
Yes. Yeah, colleagues, but let us give our learners the updated information, please. Updated documents. And later on, when we teach, please let us use the updated information in our teaching. Okay?
We are not sure if we understand that very well. Where 541, where they put an R, are they not already giving us a particular name or a compound? They are not giving the bone structure.
Yeah, but the R means it can be anything. Can a chain can increase or can be hydrogen. That is what an R usually actually meant back then. It can be anything.
Yeah, but then if they do that, then they are already giving you a certain structure of carboxylic acid.
But which structure will you say that is?
Any, it can be anything from economic, the last one. So
which is correct. That this board yes.
Yeah, it's our contribution for our as it is like this, it should just be there because anything can come after that. It can either be an H or it can be another chain of carbons.
Which R represent? R actually represents anything. Can be an H or a chain of carbons. That is what R meant or means, for those of us who taught 20 years ago.
Okay, now when we kill in that, thank you.
Yes, so yeah, it's fine. I think the teacher is the one who maybe gave the learner this information, but it's okay. Let us accept it for now, colleagues, but please let us caution our learners. Can we move on to question number 6? I take it we do not have any hands. Question number 6 is about the physical properties, colleagues. A group of learners investigate the effect of different factors on melting points of different organic molecules of comparable molecular mass. The results from their investigation are shown in the table below. Then the first question, the learners were then asked to define the term melting point. When they define the term melting point, this is what we expected from our learners. The temperature at which the solid and the liquid phase of a substance are at equilibrium. The temperature at which the solid and the liquid phases of a substance are at equilibrium. Colleagues, let us give 2 or 0 here, please. Let us give 2 or 0. All the underlined weights must be there. I do not see how can a learner omit any of these weights and still have the correct context. I can't see from here. From where I'm standing, I can't really see. Or which weight can a learner then omit, and then the definition still makes sense, or it is still, or will be in the correct context. I can't see. So let us say it is 2 or 0. 6.2, then learners were asked to explain, to fully explain the difference in the melting points of butane and methyl propane. Butane and methyl propane. So here we are comparing compounds from the same homologous series. We know, colleagues, or if we are comparing the physical property of compounds from the same homologous series, we'll then use the structure, colleagues. And in the structure, we can talk of the chain length or the branches. So a learner can say butane, when compared to methyl propane, has less branches. We can accept a larger surface area than methyl propane. 1 mark for this part. And we know the one with less branches consists of stronger intermolecular forces. Then butane consists of stronger intermolecular forces than methyl propane. 1 mark. And then the last point, where the learner then will then have to compare the amount of energy that will be needed to overcome the strength of those intermolecular forces. Then more energy is needed to overcome the strength of intermolecular forces in butane than in methyl propane. But the learner has to compare. A learner has to compare. Or a learner can start with methyl propane, saying methyl propane has more branches or smaller surface area than butane. 1 mark. Methyl propane consists of weaker intermolecular forces than butane, and then less energy is needed to overcome the strength of intermolecular forces in methyl propane than butane. That is where your 3rd mark will be. I think that is clear, colleagues, for 6.2. And then 6.3, learners were then asked if ethanoic acid is a solid or a liquid at room temperature. Ethanoic acid is a solid or a liquid at room temperature. At room temperature, which is 25, melting point is 16. Then 25 is more than 16 degrees Celsius. Therefore, ethanoic acid will be a liquid. Will be a liquid. And then the last question, not the last question, 6.4, how does the vapor pressure of propane-1-ol compare to that of ethanoic acid? Learners were then asked to write lower than, higher than, or equal to. Lower than, higher than, or equal to. Then they were asked to fully explain. That is ethanoic acid and propane-1-ol. How does the vapor pressure? It will obviously be higher than of propane-1-ol than that of ethanoic acid. It will be higher than 1 mark. And we are tempted here to say, let us apply negative marking. Yeah, but then we said, maybe let us leave it for now, colleagues, but please let us make our learners aware that they cannot give an correct explanation to a wrong thing. They can't give correct explanation to a wrong thing. So higher than, do not apply. If a learner says lower than or equal to, do not apply negative marking. Then 6.5, they were asked to explain their answer to 6.4. So in addition to London forces and dipole forces, propane-1-ol consists of one side of hydrogen bonding, and ethanoic acid consists of two sides of hydrogen bonding. Propane-1-ol consists of one side of hydrogen bonding. That part, colleagues, 1 mark. Ethanoic acid consists of two sides of hydrogen bonding. That part will also be 1 mark. Second point, ethanoic acid consists of stronger intermolecular forces than propane-1-ol, 1 mark. And then more energy will be needed to overcome the strength of intermolecular forces in ethanoic acid than propane-1-ol. or the boiling point of ethanoic acid is greater than that of propan 1-ol, then that is where the fourth mark will be. Or in addition to London forces and dipole forces, propan 1-ol consists of one side of hydrogen bonding, 1 mark, and ethanoic acid consists of 2 sides of hydrogen bonding, 1 mark. Please be careful with the spelling of sides. Please, I don't know if we should be harsh on that. Colleagues will advise. Propan 1-ol consists of weaker intermolecular forces than ethanoic acids, ethanoic acid. Then less energy is needed to overcome the strength of intermolecular forces in propan 1-ol than in ethanoic acid, or boiling point of propan 1-ol is smaller than that of ethanoic acid. Then that is where the fourth mark will be, colleagues. And that is it. Remember, if you come across any option as you mark, colleagues, that the learners gave, and you believe it is correct, please share it with your subject advisors, and then they will share it with the examiners, and the moderators will look. They will then look at it, and then an addendum will be made, colleagues, with the options that are not indicated in the memo here. That will be it for question number 6, colleagues. Do we have any questions before we close the meeting?
Yes, there are. I'm happy. There are some hands.
Okay.
Mekrai, let's start with Mekrai.
Okay.
Oh, I'm very sorry, sir. I forgot to lower my hand.
Okay, thank you, ma'am.
Sorry, Mekrai.
No, she forgot to lower her hand. She actually does not have a question.
Okay, Mr. Moswa? We can't hear you. Tate Moswa? Can you go to, yes, your question?
Hey, I can't hear
Can
you.
Can you raise your voice? Can't hear you.
6.5. Hey, I can't hear me now.
Can you come closer to the mic, that we can't hear you?
Yes, can you please write on the chat whilst other colleagues are? Seems like we have a problem with your speaker. Please write your question on the chat, and then we'll read it out whilst other colleagues are asking their questions, because we can't hear you, Minir. Please write it on the chat there. Thank you. Next hand, Baba.
Mahula.
I don't know if I'm going back a bit. I still have a problem with question 3.3. Remember, I said 13 meters per second is the answer. I also got the 3 meters per second. So I don't know if the colleagues did calculate the final velocity of metal A. Thank you.
Yeah.
No, we need to confirm it.
Yeah. Yeah. We received one where there is an answer of 3. We're looking at it just now, but now in that, what we have seen is the learner has mixed the masses, because he's using the mass of A of B, but for the velocity of A, something like that. So he's mixing some of the masses there. So that's why maybe there is a problem with that 3. It was put in the group, but we're looking into it, but it is something that we have also seen.
Yeah.
Baba, the other
I think it will form part of the addendum.
Of the addendum. Yeah.
Yes, because I'm still using the same mass and getting 3 and 13. But then the only difference is that I choose right as positive, and the other one I choose left as positive.
Now we'll look at
yes.
it, Ms. Pan. Yeah,
Thank you. Thank you very much.
Yeah. That might be just a general thing that came across as we do. Colleagues, throughout this paper, did you find your learners writing definitions on one page? All of them, all the definitions. Colleagues? If ever we have such colleagues, can we ask our learners not to write definitions on the same page, all of them? It is making marking very difficult. So we don't want to see that coming up again during the end of the year. Please, colleagues. Thank you, Bob.
Thank you, Bob. Did he write the question in the chat? Maybe we can read it out. TR, I trust TR for reading us the questions there in the chat. TR. Do we have a question, Baba, in the chat?
Before I don't see anything that okay. Here's the sum for Mr. Musa. I don't see any.
Okay. No, I think we'll then talk to Ntate Musa in private, because now we are done. Memancho, do you want to have a wait before we close the meeting, man?
Okay, Baba, here is one for Mr. Musa.
Okay.
If I don't, yes, addition to London forces and dipole are omitted, do we still award full marks? I think in the memo, the underlined part, it is emphasizing that part is underlined, so the learner can be given the marks there for that.
Okay,
so
yeah.
That
is what he was asking. Okay, now we can read out.
Yeah.
Forces must be shown.
And yeah. Can I just go through these others, maybe in case we don't miss any? 5.1, it says, can we also accept organic compounds that share the same functional group?
That share the same functional group.
5.1.
Yeah, we accept.
Yeah.
Okay.
And then, or maybe the answer should be an organic compound that has the same molecular formula and has the same functional group. I think it's the same question.
Molecular formula. But it can't be the same molecular formula for homologous series. They can't have the same molecular formula. Their molecular formulas cannot be the same, okay, even though they are from the same homologous series.
Yeah.
But the functional
And
group can be the same, yeah.
Yeah. So
because of that part, molecular formula then will not give, if I understand you correct, Baba, yeah.
Okay. Those were the questions on the chat, Baba. I think we have addressed them.
Okay.
I can give over to Memancho there.
If you would like to conclude.
Okay, thank you very much, Ndate. I'm happy for the manner in which you conducted the memo discussion. It was really helpful, I think, for most of the colleagues, even the colleagues that are teaching maybe grade 12 for the first time. So in other words, they are new markers as well. And colleagues, thank you very much for your questions. I loved the discussion. I loved the manner in which you were asking questions, that just to ensure that the marking goes well. And colleagues, please let us ensure that at this time of the year, we mark as strict as possible so that we correct the misconceptions. We ensure that learners do not repeat the same mistakes in June, for example, September, and also at the end of the year. So let us ensure that we mark correctly. Don't underline or circle and then give a mark. If it is incorrect, that part is incorrect, don't give a mark. And I hope you also understand what the positive marking means. So colleagues, thank you very much for your time and all the best for everything. Don't forget to fill in the attendance register, please, and make it as soon as now, because if it becomes late, it won't be acceptable by the Auditor General. So fill in the register as soon as now. Thank you very much, colleagues. Have a pleasant and a blessed day. Thank you, Ndate Mapi.
Thank you very much.
I have a suggestion.
You have a suggestion?
Yes,
ma'am.
I'm on your phone, so I don't know how to raise a hand. I'm an old teacher. Yeah, born before technology. Yes, let's go back to question 2, the question paper.
The question paper, okay.
Yes, sir. Below the diagram is the information that both blocks are stationary. When I first answered that question, question 2.3, I had not seen that information that the blocks are stationary. So I just said to myself, I cannot answer this question. I looked at the memo and I saw that the acceleration is 0 and I didn't understand how. So my suggestion is that that part, both blocks are stationary, should be above the diagram with all the other information that is given before the diagram.
Okay. All right, ma'am. No, thank you.
The state of mind of the learner, some of them become anxious when they are scared or the first test. So after they read all the information about the diagram, the first thing says state Newton's first law of motion.
Yeah.
And then they answer that, draw the free body diagram, they go back to the diagram. Then the last part is calculate the angle. When they do that, they go back to the information given above the diagram. Then they don't see that statement below the diagram. So my suggestion is that that should also be typed together with the information above the diagram.
All right. Maybe it must be bolded, Nyana, or something.
I think that would have been better.
Yeah, no, point taken, me. Thank you very much for your suggestion. Okay. Now, colleagues, just be aware that a Google form will be sent out for item and error analysis. Please let us fill the item and error analysis, colleagues. We really do need that information. Please, colleagues. Once that Google form comes, please fill in and submit the item and error analysis for this test. Thank you very much, colleagues, for your attention and your cooperation and your engagements. That is where we'll end with our memo discussion. Thank you very much. Thank you and good luck with your marking.